When this Jeep came to us, it was a regular two-wheel drive Jeep which had leaf spring suspensions, and it was powered by a Toyota 3C engine. What we did was that we built a 4-bar link suspension setup with coil springs for both front and rear axles, and we made it 4-wheel drive, and we changed the engine to a Range Rover 3.5 EFI V8.
Gopal and Yesh from Tinsy Race Cars India have been in contact with us for some time now. We've helped them with certain technical difficulties they've had with putting the engine in the CJ Jeep.
I remember a few years back we were watching one of the episodes of Dirt Every Day on YouTube, and there was a vehicle known as the Ugly Jeep, which was titled the Ugly Jeep, and Fred Williams was mentioning how he came across this Jeep in the 70s or 80s through a magazine, and later found out that the Jeep was still existing and was working. The most charming thing about that vehicle was that it was powered by a Rover V8. When we started working on Range Rover V8s, and when you start looking at a V8 engine and at the same time you look at the Jeep chassis, then the kind of relationship that you find between the Jeep chassis and the Rover V8 is simply remarkable, because the kind of packaging that the chassis offers is really great. You feel that every other engine that has ever been in a Jeep is actually worthless, and it's only a V8 that your Jeep really deserves. When it was decided that we will be putting a Range Rover V8 in this Jeep, then we unanimously came to the conclusion that let's get RPI Engineering on board. RPI is a globally recognized name when it comes to Range Rover V8.
Rover V8s are quite popular amongst the motorsport fraternity all over the world. We feel one of the biggest reasons for this is they are easy to work on, and everything's interchangeable between 3.5, 3.9 and 4.6 litre engines. Here at RPI we build engines and supply components to get the best in terms of performance and efficiency. We achieve this by upgrading the ignition system, carburetors, or upgrading the EFI system, and of course ensuring that the customer's engine is in good condition, or by building a fresh RPI engine to start from.
We came to know about RPI when we were in college, and we used to watch Top Gear, and in one of the episodes of Top Gear, Jeremy Clarkson was actually visiting the RPI engineering workshop, and he tried out one of their Range Rover 5.2 litres petrol engine, and that was the time when we actually got to know about RPI engineering in the UK, and it was really nice working with them on a real project.
We've been supplying engines and components all over the world now for over 30 years, and we've also been involved in TV shows such as Top Gear and Wheeler Digglers, and also we supplied some of the engines for the race cars in the film Rush.
The very fact that they have provided engines for some of the race cars in the film Rush clearly shows that they are one of the best in the world. And during this entire project, Mr. Chris Crane and Ian were really supportive, and it felt like a really nice team.
And when I first heard they were putting this engine in there, I thought it was a really interesting project, and it's always nice to get involved with these kind of projects.
The gearbox that we have used with this engine is an R380 all-wheel drive gearbox, and it is a combination that comes in a Range Rover Classic. The differentials that we have used is also from a Range Rover Classic, so it completely rules out the problem that normally people face who put torquey and high power engine in their vehicles with stock differentials. So normally the problem is that the stock differentials won't be able to take that much amount of torque. But since we have used the differentials from the same vehicle to which the engine belongs, that problem stands resolved. Suspensions that we have built is of 4-bar link suspensions. We have made sure that all the brackets and everything that we have designed on the computer comes out exactly as they are on ground as well. The chassis has been strengthened to take the load and the features of the new powertrain and the new suspensions. The torsional rigidity of the chassis has been enhanced by using computer-aided FEA and by adding optimized cross members. There were a couple of things that we also wanted to do on this vehicle, but we had to draw the line somewhere because ultimately we are doing it for someone else and not for us. So, for example, earlier we had a pure racing clutch on this vehicle, but it was later discovered that it was too hard for a regular driver to drive. So we had to replace that clutch with a regular high performance clutch, and still it is one step ahead of a regular clutch, but it's not a pure racing clutch. And then brakes that we have used is, we wanted to use Wilwood, but there are cost restrictions, and we instead have used a 4-piston calipers on the front and 2-piston on the rear from a stock Range Rover Classic, so they are good enough. Earlier we had the radiator at the back and we had an auxiliary water pump on the vehicle, but later that actually made the front look a little unconventional. So we were asked to change it because what was desired was a regular Jeep look. So we removed all that setup of the rear radiator and brought it at the back with a regular Jeep grill. Ultimately, when we drive the vehicle, when we experience the acceleration, when we experience the high-speed stability and articulation while off-roading, then it really feels satisfying because the vehicle really performs well.
And from the pictures and videos that I've seen, it looks like the project's come out really well.
You always learn something new whenever you work on a project like this. Especially when it comes to something that you've always wanted to do. Like we've always wanted to put a Rover V8 in a Jeep. So it was a really wonderful experience. And of course, like there are certain things that work out, some things don't work out. So it's a really nice learning curve. So this whole project taught us a lot about the technical and non-technical aspects of building a car.